So my name's Tim Ward. I'm an engineer based out of Copenhagen, Denmark. I work for a company called CluedIn. Basically, our focus is to help companies like yourself become a connected enterprise. This is actually my third time speaking at Graph Connect. I typically talk about machine learning and how the graph can be used to aid a lot of the data preparations that's necessary for machine learning. This year I'm changing it up a little bit. I'm going a little bit more abstract. My goal is to kind of answer four main questions. What do you need to do to become a connected enterprise? How do you do it? What does it look like when you are a connected enterprise, and is it worth all the fuss? Right? What is the value that companies are actually getting out of it once they're a connected enterprise? So let's start with the problem. So essentially, this is actually what your business looks like. The data is scattered across the different systems, and it varies in quality. In fact, some systems, and I apologize if you are from SAP or IBM, but some systems are just fundamentally broken. And it doesn't help that if you take a look at the data landscape today, and you look at all the components that a company needs to become a lot more data-driven, it's pretty damn overwhelming. And I'm not even mentioning databases here. So we're talking about probably a lot of common components most of you already had already. Data warehouse, data integration, data governance, maybe cloud storage, retention polys. These are all components that are necessary to become a connected enterprise. And with the companies that we talk with, I can tell you when you talk to the business does not care what cloud provider they're using. They don't care if a query will scale or not. They care, can they get access to the data that sits across the business, and when they access it, is it ready to be used for use cases, for example, up the top, business intelligence, machine learning. All of these problems need to be solved by access to good quality data. And so what do we need to do about it? Well, here's what I'm going to do. My goal is actually today to give away all our intellectual property. And what I'm going to do is I'm going to give you the recipe that you need to become a connected enterprise. And whether you do this with a platform like CluedIn or not, there is one technology that we can't escape to build a connected enterprise, and that's the graph database. So let's begin. The first hurdle, data integration. Integration's easy, right? Well, I would concur that most developers could probably connect to a system and be pulling data from them within a day. So let's go with that hypothetical. There is such a fundamental difference between this and something that is necessary to stand up against the robustness that's needed in the enterprise. So these are the types of things you need to be thinking about if you're going to be building the connected enterprise. And it starts with the most facetious title of the day. You need to think enterprise. I can tell you that the enterprise is not authenticating with systems with usernames and passwords. They're using NTLM, they're using SCIM, they're using Kerberos. Not to mention that enterprises grow as well. They adapt new products. If you're wanting to build the connected enterprise, real-time data is a piece of this. If you don't have data integration that can adapt to new types of authentication methods, the system breaks down. So adding 2 accounts is fine. Adding 100,000 accounts is something completely different. So when you're working with these type of ETL models, pulling in data from dispersed systems, you need to be thinking about working with service accounts, not individual accounts. And when we're talking about services accounts, when we're pulling in data, that's what we're talking about, iterating accounts, discovery of new accounts. What happens, the enterprise changes all the time. People leave, new people come in. Integration needs to be able to support this type of model to actually stand up against the enterprise. And what I think is the most, ironic statement of this is that things need to be fast, but not too fast. So the problem is that if things aren't too fast with data integration, it'll be a year before you actually even start to see the connected enterprise. Some of the customers that we talk and work with have hundreds of thousands of Exchange accounts. have hundreds of SharePoint sites. In fact, if you were in the last presentation just over to the right here, you would see they had 8 terabytes worth of SharePoint. They're one of the customers that uses CluedIn. So just the sheer amount of data, we need some system that has parallelization in mind. We need something that has distributed processing in mind. But if you look at most platforms today, specifically SaaS platforms, they all have API throttling built into it. So you need to make sure that you're adhering to these levels and not going overboard with communicating with different systems. Now, the same happens in the on-premise environment. It's typically the network that is the actual bottleneck. I mean, businesses still have to run. If you're talking about connecting data from different systems, you need to do it in a live manner. You need to be pulling data from production systems. They need to continue to be up. And so there needs to be this real fine balance between fast but not too fast. Not to mention in the SaaS world, if you're using something like Salesforce, if you're pulling data from them too fast, they'll just ban your application. I mean, try telling that to your customers. The reason your data's not coming in is because we were pummeling it too fast. That's why your Salesforce data is not hooked into your overall connected enterprise story. The other thing that comes up with data integration is we can leverage real-time. Most systems these days, modern systems, give us real-time support with things like streaming, webhooks, and push notifications. And for kind of on-premise software, maybe not as modern, we can actually hijack a lot of techniques that exist within those infrastructure systems already. Things like triggers in databases. You can actually use those as a kind of mechanism of reacting off change and pushing it to other parts of the enterprise. Not to mention that scheduled downtimes is just a common thing that happens in the enterprise. So we need to have resilience built into our data integration pipelines that are thinking about we might not be always able to crawl and fetch the new data. We might need to fit into some type of model. So these are the types of things that come up in the enterprise when you're actually trying to build a connected enterprise. It's something that you don't easily see when you're building that small proof of concept of pulling data from one system into another. So these are really the things that you need to be thinking about. So the second and the biggest hurdle is actually something that's often skipped as well. There's no use serving bad quality data to your business. So there is a huge data preparation and cleaning step that we need to look into. And before I start going directly into the graph database and how it helps in this process, we need to do some things first. We need to prepare some things before we head into the graph. I don't think I'm bold to say this because, in fact, Emil says this himself. There are 15 types of database families today. And most companies are still trying to solve their data problem with one or two, the relational store or a columnar database, the kind of data warehouse approach. This is great. Data warehouses solve a big problem, but they're not the connected enterprise. And so at CluedIn, and if you decide to build this engine yourself, at CluedIn we actually use 5 different types of database families. Because all of these database families were built and designed to solve a specific problem in data. Too often, you've been hearing from people, we bend a database to do something that it shouldn't. So we should take this quite polyglot approach to utilizing the actual database technologies, storing the same data prepared in different formats. This becomes handy later on when we're actually starting to want to utilize the data across our business. So there is an automatic part of cleaning data, and there is a manual part. And there is just so much more that you can automate in the data cleansing environment today because we can utilize multiple different database technologies. What I would ask you to do is, we've been spending the last 4 and 5 years building a platform that helps companies build their data fabric or become much more data-driven or build this connected enterprise. What I would ask you to do is actually pay close attention to the ordering of this cleaning, because this is something that we've actually optimized quite a lot over time to increase not only efficiency, but precision of the automatic data cleaning. So the first thing we need to look at is classic normalization of data, right? Normalizing dates into a standard ISO format or culture, normalizing locations into a standard normalized representation of that location. This is, pretty common in the data world. I'm not telling you anything new. But a lot of this can be automated. This is not something we necessarily have to break out the code for yet, or break out these classical kind of ETL cleaning tools that some of you might be used to. Now, one of the next critical pieces to make this work is you actually need to start scoring your data. We at CluedIn use 6 different metrics to score the data, and I know that all these sound quite synonymous, but in the data world, they're very different. And the metrics that we use are completeness, relevance, validity, staleness, quality, and accuracy. And basically what we're going to be doing as we send this data through a pipeline, we're going to be moving these scores up and down, depending on the output of those different functions. Because what we're going to do at the end is we're going to determine if what we have done in the automatic cleaning part is statistically confident. So keep an eye on this. Now, I'm staying quite abstract on purpose, because my intention for this is for you to actually go back through this video at later points when you're wanting to solve this problem at your workplace, and actually just focus more on the recipe itself. I know it's easy to stand here and say, just categorize your data. Maybe sometimes it's harder to actually do that than just say it. But if I was giving you a recipe on to how to bake a cake, I wouldn't be telling you how to make flour. Because there are certain techniques that is well-known techniques to categorize data. But the critical thing I want you to get from this is the stage within the processing pipeline where we actually want to do this. Because there's other parts that are going to be coming up where we will need this data to be strongly typed. So just something as simple as changing a document into something like an invoice or a contract. Classifying users more as a sales lead or a customer. That's what we want to be doing at this step. And actually, it's only now when we want to start looking into merging data. So we want to start merging data in the graph based off unique references. And here is, I think, one of the most kind of big giveaways of how we do it and how I would suggest you do it as well, and that yields pretty damn good results. And that is, you need to work with a data model where it doesn't trust the data source where the data is coming from. And one of the things that the graph database helped us solve is that joins are no longer a problem for me. If I was trying to merge data and I was shoving it into a relational database, I would very much have to think about what's the database schema where we're pulling this data from. How many database schemas do you think stand the test of time? I'm sure they all started out with fantastic intentions, but over time people have left, tables have been added, the schema integrity has not been updated. And hence, what I would argue is a better approach is that at this point, all we need to tell from our data that's coming in through our integration pipeline is what is unique, not how is it referenced to other things within that data source. I'll touch a little bit more on this later. What this helps out with is this particular problem, is that the referential integrity of the database, even if it was intact, just classic things like I've got 2 databases where in one database we have a column called contact and in another it's email, right? You and I look at this and we say, I know that's the same thing, but I don't know through the referential integrity that there's a connection there. So this approach of just being able to highlight, this is a unique reference to an individual, that's all we need to do at this point. Because what we are going to do is we're going to flip this classic ETL process into an ELT process, where I actually want to have a full view of all the data before I start looking into finding how these things are related to each other. One of the optional steps that you have now is to utilize external data sources to help you. We work a lot in the data privacy and compliance space, and that's why I also recommend that this is optional at this step. When you're working in that space and you're wanting to build a data privacy product, typically the less data you have, the better, the less liable you are. But what this can help us do is it can help us use not only paid services, but quite a lot of online services that have free data sets. I'm talking about, well, in the US alone, you've got the SEC, which has a lot of business data, a lot of data on who are the founders, who registered the business. You've got Open Corporates, which is an open data set of company and business people. You know, we can start to look at these external sources to help us not only enrich data, but to help us triangulate data. So this is the best case of me saying something that is extremely difficult to solve, but I have a good answer. It's now that you need to look into fuzzy merging. This is the part of the pipeline of cleaning and data preparation. If we're wanting to actually use the data that we have across the business, we have to do this kind of stuff. It's now when we get into the fuzzy merging. Now, you and I can probably look at these records and say, it's probably the same person. It's much harder for a machine to do this. What I would actually rather you do, instead of me explaining again, the last two Graph Connect conferences that we actually spoke at, we went into detail on how to solve fuzzy merging. So this is merging records, deduplicating records where there's no obvious unique overlap or easy way for a machine to tell that these are the same records. It's worth reminding you now at this point that we need to make sure that we're also tracking the lineage of every single change that we make. Because in the nature of data, I can guarantee you after running in production for 5 years on enterprise customers that you will always need to revert some data. There is always a decision made on data at this point in time where in 3 years it's irrelevant or wrong. And so for those of you who are engineers in the room, the easiest way to think about a proper object model for this is to think about Git, the source control system. Git works off a versioned object graph. It's essentially a big network or tree or graph of storing all of the different changes of data over time. Using this versioned object graph, it actually allows us to revert back to parts within history and to replay things or remove components that were necessarily wrong. Also, just from a lineage and a black box perspective, to kind of not have a black box of magic cleaning, it's also important at this point to track what have we automatically cleaned. Did we turn CPH into Copenhagen? Did we turn a date of birth in the US format into much more of a universal culture instead? We need to track these changes. This is just a small reminder that as we're going along, every choice that we're making, we are moving these scores of accuracy, quality, completeness up and down. Obviously, if we're able to improve the quality of something like a phone number, this is my phone number up here, 53 84 15 16. There is a better version of that number. If you know where I live, you'll know that Denmark has +45 as the dial code. That is a better representation of the data. So that's one of the ways that we would increase quality of data. Not necessarily accuracy, but quality. Completeness is a little bit easier to understand. If you've got a CRM record and it's missing an address and missing a phone number, it's an incomplete record. So here comes the graph. Because I would argue that this is where most companies have got to. They're taking a metadata approach to cleaning data. So when we actually try to solve this problem with the graph, taking that metadata example in the previous slide, it was slightly fuzzy, if not hard, for us in the room to figure out if they're the same person. Much harder for a computer. But if we start looking at the data around these records, it starts to reveal a context that makes this much easier. It's also worth mentioning that this isn't about solving this one way. This is about using all of these techniques to build up a statistical confidence over what we're automating. That's the critical point. So if we take something like looking at the data that's connected indirectly or directly to these nodes, it becomes much more clearer to figure out that there's maybe something to do with Emma Smith and Emma Fitzpatrick. Not to mention that one of the powerful features that the graph gives us is shortest path queries. Imagine Emma at completely different dispersed parts of our graph. What we can start to do is not only run these shortest path queries, what we're actually wanting to do is, as we traverse these paths, we're wanting to see what's the overlap of records. How many records are overlapping in these paths between these two nodes? Maybe the same company, maybe the same projects. These are all, once again, more clues for you to be able to determine that these records should be merged and deduplicated. So then unstructured data comes in. How are we solving this today? Figuring out who Emma Smith is in this unstructured email body. We're probably taking a natural language processing technique. We're probably using a named entity recognition to first detect if that's a person. If you use most of the libraries that are available, you'll know that the models don't really work very well. You have to build these models yourself. Next, we'll do a dependency parsing to basically break up our sentences into subjects, objects, nouns, pronouns, verbs, adjectives, etc. And that will help us map the relationship of data within the context of this document. But when we actually start to step outside the document, there is such better precision that we can get around Emma Smith. She might be directly connected to that document via some other reference, not necessarily something you would get in metadata, like author of, or created by, or last modified by. It might be some other reference we've got from somewhere else. So in fact, without us knowing, the graph can actually be utilized to really help us solve this problem of references to individuals and companies and tasks and things like this within unstructured content. But there is absolutely no magic to this. There is only so much that you can automatically clean and prepare in your data. And so at CluedIn, we basically give two different tools. One's targeted towards data engineers, and one is targeted towards business users. The data engineering tool, you can already buy those platforms on the market. If you've used things like Talend or Pentaho or Google Data Prep, things like this, that's basically what we do as well. We provide a platform called CluedIn where we break out the data that's dirty and incomplete. We break it out and we get into a tabular view and we give it to engineers. This is where things become interesting, is that we can actually give business users a way to be able to curate and steward the data as well. The reason why this becomes interesting, especially with the graph, is that if we have mapped your enterprise into a graph and we need to answer a question around a particular node, we know who are the most connected people to that node. They are the people we should be asking the questions to fix this data. So let's have a look. So from the manual cleaning side, think of CluedIn Clean, think of Talend, Pentaho as this kind of classic loading our data up, getting kind of classic Excel pivoting functions to cluster data to solve these problems like what if gender is male, female, M, F, 0, 1, unknown, depending where it comes from different systems. That's what this is used to solve. Because these are sometimes classically hard to solve in an automated way. You don't need to use a tool like CluedIn Clean. You could use a tool like Talend or Pentaho. It solves the same problem. This is where it becomes interesting. How many of you heard of this kind of trend now of data culture, right? It's this idea of business people close to the data should help us curate things. They should play some role in adding context for what is essentially may have been entered as incorrect data. And so what we use is a technique in CluedIn Train called reinforcement learning. It's not about asking business users whether they should correct data. It's about asking users, did we do something right or wrong? Without you knowing, what you're actually doing is helping this processing and cleaning pipeline, the automatic piece, get better over time. Because literally you're just telling it a mechanism, you did something wrong, so whatever you're doing in the future, always analyze that maybe if you're going to fix those types of same things, you might be doing that wrong. So think of it like bringing up a child. So if you're teaching a child maybe about don't touch knives and touch the teddy bear. I don't give my child knives, by the way. If you tell him immediately, don't touch that knife, that doesn't mean that the next time he won't touch it. But if I drill that into him multiple different times, over time, he will be able to build up that statistical answer of, in this particular case of touching a knife, I usually should not do it. It doesn't stop him from doing it, but statistically, he will not touch that knife in the future. This is the same technique, but just with data. So for example, if we detected that spicy chicken is a person, you don't need to say, no, it's actually Stephen Chicken. Of course, no one's going to be named Stephen Chicken. I apologize if there is a Stephen Chicken in the audience. All you need to do in this technique is actually say, no, you did that wrong. It's about building up statistical models, and here's what this solves. Your company data looks so much different to my company data. And, for example, one of the banks we work in Denmark, their HR data looks extremely different to our HR data. And this is something where actually machine learning becomes very, very useful. Not to mention that exposing the graph to your users to be able to correct data is one of the other pivotal steps. There is some data exploration that needs to be shown in a network. It cannot be consumed as easily if it's shown in tabular view or document view. That's where the graph becomes handy as well. So the ability to correct things that have been done incorrectly. Here's why. This is not about solving everything up front. This is why most companies don't start this to solve this problem, is because it's too overwhelming. As long as we take this approach of I have mechanisms to be able to increase this over time, this is what makes it work. This is what allows companies to become a connected enterprise. So now we can revisit this point. The whole pipeline, we've been moving these values up and down. And really what it is now, this is where it becomes interesting, is because it's up to the business to actually set the service level agreement of what's acceptable of data to serve to the business. So it's a business decision at that point. All we will do is if the business sets the SLAs too high, 90% quality, 90% accuracy, do you know what that's going to do? It's going to generate more data, including clean and CluedIn Train. So the third hurdle, making this data accessible to the business. So we've integrated data. It stands up to the enterprise because we've been thinking about networking and the fact that networks are unreliable. We've been thinking about scheduling. We've got fast, but not too fast. We're authenticating with enterprise-level security, but we're also adaptable to that authentication changing over time as that enterprise grows. We have an automatic cleaning technique that can help us automate a certain percentage of the data, but not everything. The graph really helps because we can start to ask new questions of our data in the cleaning process that we can't ask a relational database. We can't ask a document store. So now we want to use it. There is one querying language that makes complete sense for this, and it's GraphQL. GraphQL actually has nothing to do with a graph database at all. Kind of an inaptly named querying language. It's an object graph. So essentially, it's a kind of an abstract syntax tree. You can implement this querying language however you want. Why it becomes interesting is that if you followed this recipe and were storing your data in 5 different databases, if we write one GraphQL query, we can have different parts of the query being run by different databases. So for example, I'm extremely biased in this because I worked on this project called the Lucene project. It was quite timely that Neo4j released their full text querying today. I didn't plan on them doing that. But we use Elasticsearch for that. Elasticsearch should be doing full text querying because it handles languages and it handles problems around what's called per field analyzers. It's a very purpose-built search indexing engine, but it's not good at serving connections and graphs. So the ability to use GraphQL to basically have different parts of the query service from different databases makes this not only extremely flexible, but scalable. Because suddenly we can ask the right database to run the right queries that it was designed for. So what this really means, if we've integrated things, and if we have unified data through the cleaning process, I basically have a query language that doesn't need to join any data. I've got pre-joined data now. So even if there were records on you in a CRM and another records in another CRM, it's pre-joined at this point. So the querying speed is fast. Not to mention that using streaming technologies, you can use GraphQL to subscribe to querying of data. And as soon as that data comes in from your system and matches that GraphQL query, you can stream it off to different services. So what this looked like in the end for you is that now you have a universal querying language to talk to any data source, no matter if it's a relational database or a SaaS product or a Neo4j database, in a consistent querying language with a consistent model. So no longer do I have to write queries where I actually need to know how to talk to Salesforce at all. I can, of course, run quite abstract queries like, go get me people that earn over this much money. I don't care where they came from. So this is the kind of reaction you would get with a connected enterprise. Data comes in, data goes through the cleansing process, potentially the enrichment process, and now I can serve it something that's much more ready to the business to any of the use cases that are running up the top. This could be social data, it could be support tickets, it could be mail, it could be CRM records. So why even do this? This is the last thing I wanted to cover. Like I said, you have a consistent way to talk to your data and fuel things like this. Too often I see companies investing in amazing business intelligence tools and connecting it directly to the source data. So all of that dirtiness, the duplication of data, it's often obfuscated at this point because the charts look beautiful. Wouldn't you like to fuel this data with a connected enterprise? Something that has gone through the cleanliness process, that it's in a uniform model, much more ready to use with tools like Power BI, Tableau, Click, etc. Not to mention one of the common things, I went to the Ernst & Young talk. He said the most requested thing is a unified view of the customer. Graphs are fantastic for this. Governance. So one, ability to govern data in a universal way across your entire stack, to detect things like PII data, to detect categorization and distribution of data, to be able to detect where maybe there's breaches of regulations in different areas. Enterprise search, to be able to pivot and search across all my data points from one single place. And finally, machine learning. Machine learning is nothing without good quality data. And you don't go far in our data world without reading that most data scientists spend anywhere from 60 to 80% of their time in just cleaning and preparing data. So I will thank you for your time, and if you're interested in chatting, I'll be out, of course, in the networking drinks. I'm always happy to talk about building connected enterprise, how some of our customers have done it, and what value they've got out of it. Thank you.